scientists! My name is Joy and welcome to another Nature Memoir online class. Today is part 3 of our series What's the Matter, which is all about chemistry and all about the states of matter. So today we're going to be just talking about chemicals reaction. So let's get started. Okay, in the last video, we talked about physical reactions and how in matter you have these changes and the molecules rearrange and you can go from one state to another state. Today is all about chemical reactions. The chemical reaction is when you have those atoms and molecules rearranging together. Bonds that are broken and bonds that are formed, but the result is a new substance. For example, let's talk about cookies. Cookies are a great example of a chemical reaction. You start with ingredients, eggs, flour, baking soda, and your result is a cookie. Your ingredients are not the same thing like the cookie is. You start with something, you end up with a different product. Now, there are two different parts of a chemical reaction. There is something called reactants, and there is something called products. Reactants on the left side, and then you have the products on the right side divided by this little arrow. Okay, the arrow symbolizes the change that happened from your ingredients, if we're talking about the cookies, to what your products will be, what will be the cookie in this case. Now, for example, in this reaction, you have two reactants. You have A and B that are bonded together. And then you have C and D that are bonded together. Those are called the reactants. When they are rearranged due to energy, A and B bonds break, C and D bonds break. Now A bonds with D and B bonds with C, creating two different products that are different than your reactants. So you started with A, B, C, and D, and you end up with the same A, B, C, and D. The only difference is they are arranged differently, creating a new product. So, are you ready to see an example? Let's do this. Okay, scientists, a great example of a chemical reaction that we see all the time, it's when you light up a candle. There is something inside the candle that are producing combustion, which is what we see. It is producing light and heat. But how does that happen? Candles are made out of these molecules called hydrocarbon. It's a molecule that has carbons and hydrogen. This little black ball is going to represent my carbons, and my hydrogens are represented with these white little balls. And those carbon and hydrogens in the candle are reacting with the oxygen that is in the atmosphere. These two little Play-Dohs represent my oxygen. Oxygen is a type of atoms that like to hang out with other oxygens in the atmosphere, so that's why I have two oxygens in here. When the heat is added to this reaction, the bonds of the hydrocarbon break and the bonds of the two atoms of molecules that are together in the atmosphere, they break and they combine with each other, creating a new bond. And the product is these hydrogens now go with the oxygen, creating H2O, two hydrogens, one oxygen, and that is what we call water. Now these two oxygens go and bond with your carbon, creating CO2, or in other words, carbon dioxide. That's your product. We started with the same atoms and we end up with the same atom. That's what we call the conservation of atoms. There is nothing new, just rearrange, creating a new product. Now, what will happen if we remove some of the reactant? So I have this cup over here, and what I'm going to do is I am going to cover one of these candles, and I'm going to limit the amount of oxygen that is going to be reacting with the candle. And let's see what is going to be my product. Little by little, now there's no fire. Why is that? Because limiting the amount of oxygen that was reacting with the hydrocarbons from the candle, after there was no more oxygen to react, then the combustion stopped. Now we are ready to do another great experiment. Are you ready? Let's do this. Okay, scientists, now you saw how a chemical reaction occurred, but how do you identify that a chemical reaction has happened? Well, there are 5 indicators that you can observe that a chemical reaction has happened. What are those? Gas, the formation of gas, the formation of odor, which means a smell, the formation of a precipitate, which is like a type of a solid, the formation or the change in color, and the change in temperature. Those are the 5 indicators that a chemical reaction has happened. But you don't need all of them to happen to be an indicator of a chemical reaction. So only one needs to be present or required in order for you to call it a chemical reaction. Let's start one by one. Let's start with the formation of gas. When you have certain substances that combine, sometimes a gas is produced. That is an indicator of a chemical reaction. For example, we just did it with our candle. We light it up, gas was formed, that now we know it was carbon dioxide. That is a chemical reaction. Or another example, my favorite, campfire. You have logs, you put them in your campfire, you light them up, and you can see this smoke coming. That is a chemical reaction because a gas has been formed. Sometimes you mix 2 substances and you can see these bubbles coming out. That is an indication that a gas has formed, which is an indicator that is a chemical reaction has happened. Now, indicator number 2, the formation of odor, which is a smell. For example, in the broccoli has sulfur inside, and when it's broken down, it actually releases a very unpleasant smell. That is also an indication of a chemical reaction. Another indication is the change of color. When you mix different substances and you get a new color, you know that is a chemical reaction. One of my favorite examples, bananas. You have a banana, you leave it on your counter. Some chemicals inside the bananas start like mixing and reacting with the oxygen, turning your banana brown. Indication of a chemical reaction. Another indicator, which will be number 4, is a change in temperature. But there are 2 different things that could happen. And those reactions are called exothermic reaction or endothermic reaction. An exothermic reaction is a reaction that releases heat, makes things hotter. For example, our candle. But what is an endothermic reaction is the opposite. That reaction absorbs heat, making that new product colder. Now, our 5th indicator that a chemical reaction has happened is the formation of a precipitate or a solid. For example, you mix 2 substances, and at the end, when you look at your beaker or whatever you're mixing them, you can see a little bit of solid form, and we're going to be doing an experiment in a little bit, so just stay tuned. Okay? 5 indicators of chemical reaction. Now we're going to go into do some experiments, and I'm so excited. Let's do this. Okay, scientists, so what are we going to do first? Well, the indicators that we're going to be observing in these experiments are the formation of gas and the change in temperature. Temperature changes and gas formation usually happen together. Okay, so normally when you can see gas releasing, you're going to see a change in the temperature, which we saw in the candle. But what are we going to do now? We're going to be using household items so you can do these experiments at home. We're going to be using vinegar, which is acetic acid, and we're going to be using baking soda, which is sodium bicarbonate. And we're going to mix them together in this proportion. We're going to use 1 part of baking soda mixed with 2 parts of vinegar. In this case, we'll be using 70 grams of sodium bicarbonate, which is the baking soda, with 100 milliliters of acetic acid, which is the vinegar. And we're going to monitor the temperature because we are expecting a change in temperature. So let's take the temperature before. We have our thermometer right here. So the temperature of the baking soda is around 70 degrees. And now we're going to take the temperature of our vinegar, and it's around 70 degrees as well. Now, what we're going to do is we are going to pour the baking soda into this big beaker, and we are going now to add our vinegar on the top. A lot of bubbles are forming, and those bubbles is the gas that is escaping from the solution, which is an indicator that a chemical reaction has happened. Now, when the acetic acid, which is the vinegar, is mixed with the sodium bicarbonate, which is our baking soda, those are the reactants. The products, they produce something called sodium acetate and water. And of course, they also produce the carbon dioxide, which is all of those bubbles that you can see escaping from the solution. Now, time to check the temperature. Now, the temperature of this solution, it's now around 60 degrees Fahrenheit, which is less than what we started before, indicating that this is an endothermic reaction. Very simple experiment that you can do at home of a creation of a gas and change in temperature, 2 indicators of a chemical reaction. Now, let's go to our next experiment. In this experiment, we're going to be observing 2 different indicators that a chemical reaction has occurred. One of them is going to be the change in color, and the other one is going to be the formation of a precipitate. Remember, precipitate is a type of a salt. Let's start with what we're going to be using. Over here, you can see that we have made a solution of copper number 2 sulfate in water. This solution, we are going to add it to our test tube all the way to the middle. Now, next step, we're going to use ammonia, and we are going to add to our solution of copper 2 sulfate 15 drops of ammonia. And let's see what happens. Super cool! If you see in our test tube, you can see that on the top there is a change in color. You have a little kind of like a layer of a darker blue, but right under this darker blue, you can see a formation of a white precipitate. 2 indicators that a chemical reaction has happened. What we're going to do now is we're going to take hydrogen peroxide, and we are going to add 15 more drops to our test tube and see what happened. You can see, obviously, there was a change in color. And you see the precipitate also change color. We also see a formation of gas. So all of these activities are telling me that there is a chemical reaction right happening in this test tube. Change of color, formation of precipitate, and even the formation of gas. Now, are we ready? Let's go for review. Okay, scientists. So in this lesson, we have been talking about chemical reaction. We saw how atoms and molecules rearrange together, forming or breaking new bonds and creating new products. So the chemical reaction is the formation of a new product. We start any chemical reaction with something called reactants. Those are the ones that are going to mix together, and then we end up with something called the products, which are going to be our results. We discussed that there is a law called the conservation of atoms, because matter is not destroyed or created, just transformed. When the candle was burning, that was an example of a chemical reaction. Then we also see how the atoms arrange, not making new atoms, just with the same atoms, when we did the experiment with the Play-Doh. Another thing that we discovered in this video was what are the indicators of a chemical reaction. And those indicators were 5. We talk about the formation of a gas, the formation of odor, which is a smell, a precipitate, change in color, and change in temperature. And those were the indicators that a chemical reaction has occurred. In the experiments, we did 2 experiments today. In one of them, we observed how when you mix baking soda and vinegar, gas is formed and the temperature actually decreases, which are 2 indicators of a chemical reaction. And in our second experiment, we observed the formation of a precipitate and the change in color. Plus, we also see a little bit of gas forming. So this is our last What's the Matter Nature Memoir class. If you want to do this experiment, please let us know in our social media. And remember to like and subscribe to keep watching these educational videos and fun videos from home. And remember to join us next time to discover the truth in nature's voice. Bye, scientists!